Dear friends, in this video, we will look at linear programming part 2 that deals with formulation steps with an example. What are the steps in LP formulation? Identify the decision variables. That's the first step. Formulate the objective function in terms of the decision variables. Formulate the constraints in terms of the decision variables. And we will have to also emphasize, as a matter of fact, all decision variables are either positive or zero. That implies it is non-negative, either positive or zero, non-negativity constraint. It could be zero, but it cannot be negative. Now, let us illustrate this with an example problem. A very simple example I'm taking in order to grasp the essence of linear programming. One of the divisions of a small-scale unit manufactures two products. Both the products require two raw materials, and the consumption in kilograms per unit production is given below in the table. As you can see, product 1, product 2, raw material 1, raw material 2, maximum availability per day. And product 1 requires 2 units of raw material 1, and product 2 requires 3 units of raw material 1. Product 1 requires 1 unit of raw material 2, and product 2 requires 1 unit of raw material 2, and the maximum availability is not to exceed 18 kg for raw material 1 and 8 kg for raw material 2. Further, the problem states the profit per unit of product 1 is $15 and product 2 is $21. The maximum quantity of product 1 that can be sold is 4 units. You will have to help this small scale unit decide how many units of product 1 and product 2 be produced so as to maximize the total profit. Sorry. Now, how do we formulate this problem? Let us apply the steps. First step, identify the decision variables. So we symbolize, let X1 be the number of units of product 1 to be produced per day. Let X2 be the number of units of product 2 to be produced per day. These are symbols so that we can formulate the problem in an easy manner. Formulate the objective function in terms of the decision variables. The profit per unit of product 1 is $15 and product 2 is $21. If you produce X1 units of product 1 and X2 units of product 2, it's very clear the total profit could be written as 15x1 plus 21x2. And this is the goal or the objective that has to be maximized. In the parlance of linear programming terminology, we write the objective function as Z is equal to 15x1 plus 21x2. Z is to be maximized. Formulate the constraints in terms of the decision variables. The maximum quantity of product 1 that can be sold is 4 units. So X1 less than or equal to 4 is the sales constraint. The maximum availability of raw material 1 is 18 kg. To produce X1 units of product 1 and X2 units of product 2, you need 2x1 plus 3x2 kg, so that 2x1 plus 3x2 less than or equal to 18 raw material 1 availability. Similarly, we can work out the raw material availability constraint for raw material 2, and it is x1 plus x2 less than or equal to 2 raw material 2 availability. Because each product requires only 1 kg of raw material 1 and 1 kg of raw material 2. In order to have clarity, you go back to the previous slide, the table, to confirm the constraints of raw material and the sales that we have done. Now we completely simplify this in a canonical form and display this in order to solve the problem. This is the complete formulation in canonical form. Maximize Z is equal to 15x1 plus 21x2 subject to x1 less than or equal to 4, 2x1 plus 3x2 less than or equal to 18, x1 plus x2 less than or equal to 8, and x1, x2 greater than or equal to 0, non-negativity. And this is the complete formulation for the example problem we have taken. This, I call this as part 2. This part, I call this as part 2, where we have discussed the formulation steps with the example. Thank you very much. We will see you soon in the next video.